Hello students, all of you welcome to Future Doctor NEET Academy. Today I am going to give 7 problems in coordination compounds. Okay. So already I given these sums yesterday. Today I am going to solve the 7 problems in coordination compounds. Okay. Let us see the first question. Simple one. Primary and secondary valency of platinum in platinum En2Cl2. Okay. This is a complex. Okay. So we have to find out primary valency as well as secondary valency. Okay. Primary valence means nothing but oxidation state we have to find out. Okay, so oxidation state nothing but here it's a neutral complex. No, it's a neutral complex. Okay, so simply oxidation state of central metal ion, that's called primary valency. Okay, so here platinum is I considered X. Okay, En is a neutral ligands. Neutral ligands means 2 into 0, just I put 0. Chlorine, it's a negative ligands. For one chlorine, charge is what? Minus. Okay, here 2 chlorine, no, so minus 2 is equal to 0. So X is equal to what? Plus 2. So here, so primary valence nothing but 2. Okay, right. Secondary valence nothing but just remember it is a coordination number. Secondary valence nothing but coordination number. Okay, so coordination number means how many, what is coordination number definition? Number of coordinate bond around central metal ion. Number of coordinate bond around central metal ion is called coordination number. So here, it's a bidentate ligand. No, bidentate ligand means each bidentate ligands can make 2 coordinate bond. So it makes 1 En can make 2 coordinate bond. 2 En means it makes what? It makes 4 coordinate bond. Chlorine is a monodentate ligand. So each chlorine can make one coordinate bond. So here 2 chlorine, no, so it makes 2 coordination bond. So 4 plus 2, 6. So secondary valence nothing but coordination number. So here 4 plus 2, 6. No. So answer 2 is primary valency, 6 is what? Secondary valency. So answer D is the option, correct one. Understood? Right. Next one. IPOC name of platinum NH3 twice ClNO2. So this is also a neutral complex. Now we have to give the name IPOC name to this complex. Okay. So here now see that first of all you should find out the oxidation state. After that you can give the name to this complex. Okay, so oxidation state means here it's a neutral complex. No, so platinum I considered as X. This only we have to find out the oxidation state. No, amine is a neutral ligands, then I put 0. Understood? Chlorine is a negative ligands. 1 chlorine is there, so I put 1 minus. NO2 is also negative ligands, so what? Minus 1. So is equal to, is a neutral ligands. No, neutral complex. No, then I put 0. Therefore X is equal what? X is equal what? Plus 2. Understood? Right. Plus 2. Where is plus 2? Here, oxidation state is represented by 2. Or Roman letter 2. All are 2, 2. So anyhow, this will not there, no? This will not come, no? Okay. Understood? Right. Next one. Name. Come to the name. How to give the name means here we have 3 different kinds of ligands. One is amine, one is chlorido, one is nitrato-N. Okay, nitrate. See, if you have different kind of ligands, say the ligands in alphabetical order. That's very important. So this is amine. No, amine, chlorido, nitrato-N. So in alphabets, amine, A comes first. So amine only we should say. How many amine? We have 2 amine. No, so diamine, chlorido. The NO2 nothing but what? Nitrato-N. Nit is a ambidextrous ligand. Nitrogen only is a donor atom. Then I am saying what? Nitrato-N. Understood? So diamine, chlorido, nitrato-N, platinum. In a complex, you should say only platinum. Don't say platinate. Whenever anionic complex only we should say the metal ends with 8. But neutral complex and cationic complex, you just say metal only. Understood? Okay. Platinum. So platinum, we found out 2. Understood? So among these 4 options, D is the correct one. Sorry, C is the correct one. Understood? Right. Are you following? If you have 3 different kind of ligands, say the ligands in alphabetical order. Amine we should say first, chlorido next what? Nitrato. Understood? Right. Next one. First of all, you should know all the ligands. What is the backbone of this lesson means you must know ligand's name with charge. If you know these 2, then how to find out oxidation state. Okay. If you know this only means this chapter will be very easy. You must know how to find out oxygen state as well as name of the ligands, types of ligands. Understood? Right. Third one, which of the following is square planar structure? The square planar structure means what? From the hybridization only we can decide. If you have DSP2 hybridization, the complex is what? Square planar structure. Understood? So here we have to find out which one is DSP2 hybridization. Okay. So DSP2 hybridization means here. Okay. Here we have to work out on then only we can able to find out. So first of all, I am going to work out the C1. Nickel CN4. Okay. You know that nickel CN4 2 minus, isn't it? Right. The complex nickel CN4 2 minus, isn't it? Right. First find out the oxygen state for nickel. So here X minus cyanide is a negative ligands, no. So 1 cyanide minus 1, 4 cyanide, minus 4, which is equal to what? Minus 2. X is equal to what? Always we will be getting only plus value, not minus value, because we are finding for metal, no, metals are electropositive character. Then only will be getting only the positive value. Okay, so answer will be what? X is equal to plus 2. Understood? Nickel is atomic number, you must remember. Okay, CBSE board examination they will give everything, but in NEET examination they won't give. Then only just memorize the first transition series, all the atomic number. Then only you can able to solve these sums. Without atomic number, you don't know. You cannot able to find out all this. Understood? So atomic number for nickel is 28. How it ends with outer electronic configuration means 3D 8 means 8 here. Okay, just remember like this. It will be easy to memorize. 8 means 8 will come. 9 means 9 will come. Understand? 7 means 7 will come. So 3D8 4s2. Okay. In nickel in ground state 3D8 4s2. But in this complex nickel is what? What oxygen state? Nickel 2 plus, no? Nickel 2 plus. Understood? So nickel 2 plus means what? Loss of 2 electrons. So this 2 electron will be lost. So it will be what? 3D8 4s2. 4s0. This will be lost. No. Then I put 0. Then see the ligands. Cn minus is a strong ligand. So first you write this one. The 3D, 3D. 5 orbitals are there. Okay. 4s means 1 orbital. Then this is 3D. This is what? 4s. Isn't it? Correct or not? Then I should put only the 4p also I should take. Then only you can able to find out the hybridization. Understood? Right. Okay. Are you following? This outer electron configuration. Nickel 2 plus means loss of 2 electron. Then we are getting this one. Now we are going to put the electrons in the orbital. Understood? 3D8 4s0. No. 3D8 means okay. Now see. Now 3D8. Okay. So here one more thing here. 3D 1, 2, 3, 4, 5, 6, 7, 8. Correct or not? Okay. But Cn is a what kind of ligand? Cn is a strong ligand. Strong ligand means what happens? Okay. It forces the unpaired electrons to pair up. Understood? Are you following? It's a strong ligand. Okay. It forces the unpaired electrons to pair up. So already we have 3 pair. Now one more pair will be coming. Understood? Now are you following? Okay. Right. See here. See already we have 3 pair. So it's a strong ligand means then it forces the unpaired electrons to pair up. Now we have what? Are you following? Okay. Now empty orbital starts here. Understood? Empty orbital starts here. Understood? Okay. Now take the how many Cn here? We have 4 cyanide. No. Each Cn giving a pair of electrons to the empty orbital. Each cyanide giving a pair of electrons to the empty orbitals. First Cn gives electrons to this one. Another Cn gives electrons to this one. Another Cn gives electrons to this one. Another one gives electrons to this one. Okay. So each Cn, okay, each Cn giving electrons to this empty orbital. Understood? Each Cn giving electrons to this empty orbitals. Understood? Are you following? Okay. From this only we can decide hybridization. See, this pair is present what? It is giving electrons to which orbital? D, no? D orbital. So D. Okay. Now it has given electrons to what? S orbital. So yes. These two has given electrons to what? P orbital. So dsp2. Any complex having this kind of hybridization, then we can say what? I already told you, square planar complex. This is called square planar complex. No, if you get dsp2 hybridization, the complex is what? Square planar. I found out this only. Okay, but you try to find the other one. Here you will be getting sp3. You will be getting sp3. Understood? Here also you will be getting what? sp3. This only will be getting what? We got DSP2. So this answer. Are you following? Understood? Right. Without know the atomic number, you cannot get. Okay, you cannot able to go solve these sums correctly. Understood? Okay. Next one. See, they're asking number of unparalleled turns. Simple one. Here also, atomic number is very important. Okay. See, chromium. First find out the X value. You know, before find out the X value, now still we studied the two complex. The two complexes are neutral complex. Okay. But here this is, you know, cation is also present, anion is also present. First of all, you split the complex into two kinds. Okay. First always cation, next always anion. So how to split this one? CrNH3. Understood? CrNH3. What? 6 times what? See here, who is present outside the bracket? Br. No. Br is a Br only. We know the charge. Br is what? Is an halogens. No, minus. How many Br? We have 3 Br. So 3 minus, no. Then I put what? 3 plus. We don't know the charge of complex. We know only the counter ion. If you know the counter ion charge, that will be opposite to that of the complex. Understood? Right. Now we have to find out the oxidation state. No. How to find out? For, you know, X, it is what? Neutral ligand. What kind of ligand you must know? It's a amine is a neutral ligand. Then I put 0. Then plus 3. No, correct or not? Okay. Therefore, X is equal to plus 3. Understood? Right. Then they are asking, what is the question? They are asking to find out only number of unpaired electron. That's the question. Number of unpaired electrons. So what? First, you know, chromium. Chromium is atomic number is what? Chromium atomic number 24, isn't it? So outer electronic configuration is actually 3d4 4s2, but we can write what? 3d5 4s1. For getting off field configuration, we can write like this. Okay. Then this is normal, no, ground state, atom in ground state, isn't it? Now in this complex, chromium oxygen is what? Cr3 plus, isn't it? But Cr3 plus. So Cr3 plus means what? Loss of what? Loss of 3 electron. Loss of 3 electron, isn't it? Meaning is what? Loss of 3 electron. Understood? Right. Now it will be what? Loss of 3 electron means 1 from here, 2 from here. Now it will be what? 3d3 4s0. Is it correct or not? Okay. Then now you put the electrons in the orbital. You know, D means what? How many box? D means what? We have 5 box. 5 orbital. Okay, right. How to fill up 3 electron? No. So 1, 2, 3. The number of unpaired electrons what? They're asking to find only number of unpaired electrons. So number of unpaired electrons is what? 3. Understood? Very simple. Number of electrons 3. 3 is what? Among the option B is the correct one. Understood? Right. Atomic number is very important. Okay. Right. The complex. See the fifth question. The complex that will exhibit maximum ionic conductivity. So maximum ionic conductivity means, you know, if you have more number of ions, more conductivity taking place, you know. So among this, which one conduct more? We have to find out. Okay. So here we have to split the compounds into cation as well as anion. So how to split this one? Who is a counter ion? Who is present outside the bracket is called counter ion. K means what's the charge? K means K plus. Understood? Right. How many K plus? 4 times, no? 4 you put in front of that. Then this is 4 plus means automatically this ferrocyanide will be what? 4 minus. So FeCN6. Understood? CN6. This is 4 plus means what? This is 4 minus. Okay. So totally how many ions are produced? 4 potassium and 1 ferrocyanide ion. 4 potassium ion and 1 ferrocyanide ion. So what? So 4 plus 1, 5. Understood? 5 ions are produced. This one. How many ions are produced? This one. Who is present outside the square bracket? Br minus, no. So Br minus. How many Br minus? 3 times. You put like this. Then what? Square bracket. Now this is 3 minus means what? Automatically this is what? 3 plus. Okay. So 1 complex plus 3 bromide ion. So what? 1 plus 3. We have 4. Understood? Right. Here what? How to say this one? How many Cl outside the bracket? Cl is charge is Cl minus. How many Cl? We have 2 times. Understood? Then automatically this is what? This is 2 minus means automatically this is what? 2 plus. So 1 complex plus 2 chloride ion. So what? 1 plus 2 what? We have 3. Understood? Okay. Now this is neutral complex. Neutral complex means, you know, no charge at all. It's a only one species. This is considered as only one species. Okay, understood. So here it will not conduct, no charge and all. No. So the complex that will exhibit maximum ionic conductivity. Maximum means which one produces more number of ion? This only produces more number of ion. No. The answer is what? A is the correct answer. Understood? Right. Next one. What is the correct electronic configuration of the central atom in K4 FeCN6 based on what? What theory? CFT theory. CFT means crystal field theory. Okay. So based on crystal field theory, we have to find out the configuration. Understood? Right. First of all, you take the compounds. What's the common? K potassium ferrocyanide, no? K4 FeCN6, isn't it? Okay, right. Then as usual, I told you just split the compound, find out the oxidation state. How to split? K4 means we can say what? 4 K plus FeCN6. Understood? How to split? 4 plus means what? 4 minus. Then as usually find out oxidation state for that. How to find X? Then one side and minus 1. So what? Minus 6 is equal to minus 4. X is equal to plus 2. Correct or not? I am doing correct or not? Okay. X is equal to plus 2. Okay. Then here is a Cn minus is a what? It's a strong ligand. Just that in spectrochemical series we are studying weak ligands and strong ligands. Okay. Cn minus is strong ligands. Strong ligands means what? Strong ligands means it is an octahedral complex. Suppose here it's a d orbitals, 3d orbitals. Okay, whenever ligands comes, the d orbital is split into two sets of orbital. One is T2G orbital, another one is called what? EG orbital. This is called T2G. That T2G is called what? EG. Okay, it's a strong ligand. No, strong ligands here. Then one more thing you should remember. That is Fe means, you tell me the Fe atomic number. All the sums we have atomic number. Without atomic number, we cannot able to do anything. Atomic number for ion is 26. So 26 means how it ends with 3d6. Correct or not? 3d6, 4s2. Then, but in this complex, Fe is what? 2 plus, no? Fe is what? 2 plus. Fe 2 plus means what? Loss of 2 electron. So what? Loss of 2 electron means what? We have 3d6 only, isn't it? That 3d6 only I put here. 3d6. Okay. Then 6. But Cn is a strong ligand. Strong ligand means all the 6 electrons is going to pair here only. Okay. Okay. If you have weak ligand means you can pair here also. Okay. We can do this here also. But it's a strong ligand means all the 6 electrons is going to pair here only. Here only. Okay. So 6 electrons how to put? You know that? So 1, 2, 3, 4, 5, 6. Understood? So here nothing. No electron. If you have weak ligand means here also we can put. Okay. But here, now what's the configuration? You tell me, what's the configuration? What? T2G, 6, no? T2G having 6 electron, EG having no electron. Understood? T2G having, okay, T2G having what? 6 electron. But EG having no electron. So EG, what? EG having 0. So now see the option, T2G 6, EG 0. That's the correct one. Understood? Still they are not asking any questions in CFT. I think they'll ask in this year. Okay, we concentrate this theory. It's very important. Mostly they're asking valence bond theory. Okay, Werner's theory based on some questions. IPOC name, isomerism. Okay, sometimes they'll ask questions from this theory also. Okay. Okay. Next one, last one. The magnetic moment of nickel Cl4 2 minus. Simple one. Magnetic moment. Okay. As usual, I told you find X value. X minus 4, isn't it? Minus 2. X is equal to what? Plus 2. Understood? Always we'll be getting only plus value, not minus value, because metals are electropositive character. Understood? Right. See, the nickel atomic number is 28. Okay. Understood? Just remember, it's a Chennai 28. Okay. If you want to memorize the nickel atomic number means Chennai 28. One film is there, no? Okay. Chennai having N will come. Nickel also having N will come. Okay. Right. So 3d8, 4 is 2. Correct or not? Right. See? No, it's a ground state. No, it's a ground state. But in this complex, nickel having what? Plus 2 oxygen state. No. So nickel plus 2. Okay. So the 2 electron will be lost. So what? Understood? Right. Understood. 2 electron will be lost. Now we are getting nickel 2 plus. No. Okay. So the configuration. That it's a weak ligand. So it will not force the unpaired electrons. No, it's a weak ligand. No. So 3d8 means you just write as it is. You just write as it is. 1, 2, 3, 4, 5, 6, 7, 8. Correct or not? 3D8. Okay. Then, if you have strong ligand means that will force the unpaired electrons to pair up, but it's a weak ligand. So, you as it is. Okay. Now, then magnetic moment is what? Therefore, not magnetic moment. First, we find out unpaired electrons. How many unpaired electrons we have? N is equal to 2. Are you following? We have 2 unpaired electrons. So, N is equal to 2. But they're asking to find out what? Magnetic moment. Magnetic moment, what's the formula? What's the formula for magnetic moment? Mu S is equal to what? Root of N into N plus 2. Are you following? Okay, right. You put it here. You know that? So 2 into 2 plus, correct only. So, root 8, no? Okay. Just remember root 8. Just remember, if you have 2 electron means 2 something, answer will be. 3 electron means 3 something. 4 electron means 4 something. Okay, just remember like this. Okay. So, we have 2 unpaired electrons, no? We will be getting 2 something. So, D is the 2 something value. So, 2.82 will come. Understood? So, 2.82. Understood? So, option D is the correct one. Understood? I hope you have understood everything. Okay. Then we will see in the next class. Thank you, students.